So today we're going to focus on using graphing to help solve them, and we'll learn some more strategies as we go through the week. So when we are talking about a system of equations, all that means is we have two or more equations with the same variables. Today we are focusing on two equations that both have an x and a y in them. But it could certainly be more than two. The solution is looking at a graph, the point where the two lines intersect or cross. So that's how we're going to solve them today. That means you have to be very good on your graph. You have to draw straight lines, because if your line is off even a little bit, it won't show you the correct point where they meet. Algebraically, that's what we'll look at starting tomorrow and the next day. It's just any point that makes both equations true. So we can plug in the x, we can plug in the y, and it works for both. There's really three possible situations when you're solving them. Either you have two lines and they cross somewhere. Okay, so we draw our graphs, we have two lines that meet. That is a single solution. It's just an ordered pair, x, y. So you'll look at your graph and you'll tell me what that point is. We could also have parallel lines. What are parallel lines?
They don't intersect and they have the same slope.
Right. Two lines with the same slope, which means they never intersect. So in that case, it is no solution. So if they have the same slope, those lines never meet, it's no solution. The third option is when I give you two equations, but when you graph them, you get the exact same line. So you graph the first one, you get the line. When you graph the second one, it's right on top of it. Then we say there are infinite solutions, because every point on that line makes it true. So either we'll have one, none, or an infinite number of solutions here. Those are the only three scenarios. It's impossible to draw two lines that meet two times or three times. This is the only way it can happen. So for us to solve them by graphing, the first thing we're going to do is make it where it's easy to graph. So we are going to rewrite in slope-intercept form, if it's not already. So we'll get it to be y equals mx plus b. Then we'll graph both lines, and then we will write the solution. We have rewritten our equations in y equals mx plus b form before. We have graphed lines before. So the only new thing is we're graphing two lines and then writing the point where they meet. Questions there? So let's actually try some. Okay. Number one, y equals x minus 8. that is already in y equals mx plus b form. So remember when we graph them, what do we do first? If you're trying to graph a line in y equals mx plus b, where does your first point go? We start at the y-intercept. My y-intercept is -8, so I hit my y-axis at -8. From there, what is my slope?
1/1.
There's nothing in front of x, that's just 1/1. So we go up 1 and over 1. You can do that repeatedly. I have to if I'm trying to draw lines up here because I can't draw them straight otherwise. That could be helpful on your papers if you need more than 2 points so you can draw a straight line with your ruler, you're welcome to. You have to have at least 2 and then use your ruler to draw your line. Do you guys understand how I got multiple points on my line? Just because I can't use a ruler on this thing, so. Alright, then we do the same thing for the second line. So y equals mx plus b, we start at the y-intercept of 1, so we hit the y-axis at 1. Slope is -2, that's like -2/1. So from your y-intercept, you go down 2 and right 1. Use the ruler to draw a very straight line. And our solution is the point where those meet. Where do they cross? So if we look, that's when the x is 3 and y is -5. So order pair is always x then y. So 3, -5. You can always check your answers here. We said it makes both equations true. Check. If you go to your equations, you replace your y with -5, your x with 3. Does -5 equal 3 minus 8? Yeah. If I did it in the second one, does -5 equal -2 times 3 plus 1? Yes. So it should make both equations true. So if you're having trouble, maybe on your graph you're having trouble deciding exactly where they meet, or you weren't sure if you did it right, plug them back into both equations and make sure it works. Alright, why don't you guys try number 2? Graph those 2 lines and see if you can figure out where they're crossing. Check out the first one. So, 1/2 x plus 9. Y-intercept is +9, with the y-axis at +9. Slope is 1/2, so up 1 over 2, or you could go down 1 and backwards 2. So there's our first line. Second one, y-intercept is 6. -1, that's like -1/1. So you could go down 1 and right 1. Or you could go up 1 and left 1. So the point where they meet is right here. That order pair, x is -2, y is +8. And you check them. You put in 1/2 times -2 is -1, plus 9 is 8. The opposite of -2 is 2, plus 6 is 8. So it works for both. Alright, let's look at this next one. Alright, before we can graph them, we need them to be in y equals mx plus b form. So, let's start with that first equation. the negative 3x plus y equals 8. If I want that in y equals mx plus b form, I have to add over my 3x. So it gives me y equals 3x plus 8. So to graph that, you hit the y-axis at 8. 3 is like 3 over 1. I don't have room to go up 3, but I could go down 3, backwards 1. First, we have to get y equals mx plus b form. Then we graph. Second one, we do the same thing. It was negative x plus y equals negative 2. So if you want y equals mx plus b, you have to add your x over. So y equals x minus 2. So to graph that, we start at negative 2. X is like 1 over 1, so up 1 over 1. Use your ruler to draw a nice line. So we're looking for the point where they meet. So remember, it's x and then y. So my x, we have to go backwards 5, so x is negative 5. Y, we go down 7. So negative 5, negative 7. Okay, we're going to do a few more of these and make sure we've got it. Problem 4. What do we have to do? Look at your first equation. What do you need to do first? We need y equals. So we want to leave the y where it is and move everything else away. So we'll subtract the x. And then we want to get rid of this 2. So I divide everything by 2. So y equals negative 1/2 x plus 2. So y-intercept, we hit the y-axis at 2. Slope is negative 1/2, so down 1 and right 2. Remember, if it's a negative slope, your line should be decreasing at the end. The second one, it is y equals mx plus b form. Y-intercept is 2, slope is negative 1/2. What happens?
It's the same line.
It's the same line. When I go to graph these, they are exactly the same line. So I only really have one line on my graph. What's my solution then?
Infinity.
Every point on that line works, so there are an infinite number of solutions. Alright, we're going going to do 5 and 6. If you guys participate and walk me through it, then I'll stop from there. Number 5. First equation, x plus 3y equals negative 15. I have to get y equals mx plus b form. So how do I get y by itself?
Subtract x first.
So then we have 3y equals negative x minus 15. What's the next step?
Three.
And you divide everything by 3. So negative x over 3, this is like a negative 1, so that would be a negative 1/3 x, minus 15 divided by 3 is 5. So if I want to graph that, y-intercept is negative 5, so we hit the y-axis at negative 5. Slope is negative 1/3, so down 1, right 3. We go up 1 and left 3. Second one, pay attention here. You're going to have one of these on your homework. If you remember what they are, they're really easy to graph. Can I put this in y equals mx plus b form? No, there's no x. If the equation is just y equals a number, what kind of line is it? Almost.
Vertical, straight. Yeah.
Remember Hoy and Bucks? If it's y equals a number, that is a horizontal line. If it's x equals a number, that's a vertical line. So horizontal, remember, is flat, vertical is up and down. So this is just a flat horizontal line at negative 7. So the point where these two things meet, x is 1, 2, 3, 4, 5, 6, and y negative 7. Last one. Y equals x plus 5. How do I graph that? What's my slope?
1 over 1.
Of 1 over 1. Next one, if I want to solve for y, what do we have to do? Subtract x. So we have negative y equals negative x plus 2. And then what? We need y by itself. We still have a negative in front, so what do we have to do? So we start at -2. Slope is 1, so up 1 over 1. What happens when I graph these two lines? They're parallel. They never cross. So what is my solution?
No solution.
No solution.